Hey, this is Andrew Brown from ExamPro, and we are taking a look at Azure Event Hub. So Event Hub is an event ingestor that can consume millions of events from anywhere and process them in real time or micro batching, thanks to the auto-inflate feature, which automatically scales the numbers of throughput to meet your changing needs. So it provides an easy way to connect with your Apache Kafka applications and clients. Here is kind of a overview illustration of event hubs. So the idea over here is you have different protocols, so HTTPS, AMQP, Kafka, for your event producers to then enter into Azure Event Hubs. You have partitions within your hubs. You have consumers. And then there is the received events, the event receivers. So, hopefully that gives you a quick overview. But let's go dive a bit deeper. Let us take a look at the pricing for Azure Event Hub. But before we do, I just want to expand on a few initialisms so we know what they stand for. We have capacity unit for CU, processing unit for PU, and throughput unit for TU. So across here, we have 4 different pricing plans: basic, standard, premium, dedicated. Lots of Azure services like to have a whole lot of specialized plans built into their services. But as you can see, as you go right, the more expensive it goes. But there's some key differences. So for Azure Event Hub, if you're on basic, you do not get capturing. Capturing costs a bit more. It costs something at standard. At premium dedicated, it's included. If you want to use Apache Kafka, you're not going to get it in basic. If you want a Schema registry, you're not going to get that in basic. If you need extended retention, you do not get it in basic or standard. So hopefully that gives you an idea of the differences of these tiers. Let's take a look at the key concepts. A lot of these we'll cover in future slides, so this one is a bit text heavy, so do not worry. But Azure Event Hub helps you build your big data pipeline to analyze logging, anomalies, users, and device telemetry, where you only pay for what you use. So some of the key concepts here are namespace. So it is an endpoint for receiving and distributing events to the event hubs. We have Event Hub, where your events will be delivered. Event Hub Cluster, which is a dedicated event hub with 99.99% SLA. Event Hub Capture, this allows you to automatically capture and save streaming events. We have Event Hubs for Apache Kafka, so this is compatibility with Apache Kafka's setup. Event Publishers, these are applications or services that publish events to Event Hub. Publisher Policy, this is a unique ID used to identify publishers. Partitions are used to organize the sequence of events in Event Hub. Event consumers are applications or services that read events from Event Hub. Consumer Group, which are they enable consuming applications to each have a separate view of the event stream. Stream Offset, which holds the position of an event inside a partition. Checkpointing is the process of distinguishing between read and unread events, but let's go look at these all in more detail. Let's talk about scaling, because that's a very important concept in Event Hub. So the idea is that there's this feature called auto-inflate, and it's basically just a checkbox here, and will automatically scale up to the maximum TU. So throughput units based on the traffic demand. It's not available for basic pricing, as we saw over there. We also have this option of, if we're in the premium tier, you're going to notice there is no auto-inflate because it's already there by default, and the unit is different. It's processing units, so you'll just slide that left and right. That's just kind of to reflect what we saw in the pricing section, okay? Let's talk about an actual event hub. So what we do is go name our hub, and we got a few options here. We have partition count. So partitions are data organization mechanisms that relates to downstream parallelism required in consuming applications. Sounds very fancy, but it's just a way of segmenting your data so that you have faster concurrent reads. You have message retention. So this is the period for which your events will retain. So that means that when they're past that period, they are gone. Then you have capture. So capture enables you to automatically deliver the streaming data in Event Hubs to Azure Blob Storage or Azure Data Lake store account of your choice, with the added flexibility of specifying a time or size interval. Setting up capture is really fast. There are no administrative costs to run it. It scales automatically with Event Hubs throughput units. Event Hubs captures is the easiest way to load streaming data into Azure and enables you to focus on data processing rather than on data capture. So just a great way to offload into Azure Blob Storage or Azure Data Lake Store. There you go. Let us take a look at producers, because that is what is going to emit events that we'll get into Event Hub. So on the right-hand example, we have some code because the idea is that you will have to instrument your producer to send out events. So here you can see we've created a client. We'll have to have a connection string, the event hub name, so we know who we're talking to. You would create a producer, and then here what we're seeing is a batch job. So they create a batch job and they push some data on there, and then they send the batch, and then when they're done, they close the client. If there are any errors, we can get some exception handling. This is a JavaScript example. So a producer, also known as a publisher, emits data to the stream. Publishers can publish events using the following protocol, so HTTPS. So most Azure SDKs use HTTPS, as this would probably use underneath. You have AMQP, which is a very popular queuing protocol. Kafka protocol, so if you're using Kafka or you're already using that protocol, then that's another way to get in here. And we just walked through that example. You can publish events either one at a time or batches, as we see here on the right-hand side. There's a limit of 1 megabyte, regardless of whether it's a single event or a batch. Beyond 1 megabyte, events will be rejected. For automation or for authorization, publishers use either Azure AD with auth to issued JWT tokens or shared access signature SAS, which is something we see a lot in Azure services. Let's just talk about some other things. So HTTPS versus AMQP for publishing events. For AMQP, it requires the establishment of a persistent bidirectional socket in addition to TLS or SSL. AMQP has higher network costs when initializing the session. AMQP has higher performance or frequent publishers and can achieve much lower latencies when used with asynchronous publishing code. HTTPS requires additional TLS overhead for every request, so it's going to be up to you to decide whether you want to use HTTPS or AMQP protocol. For publisher policies, Event Hub enables granular control over event publishers through publisher policies, and these publisher policies are runtime features designed to facilitate large numbers of independent event publishers. With publisher policies, each publisher uses its own unique identifier when publishing events to an event hub using the following mechanisms. And I guess there was supposed to be more there maybe, but I think that's pretty much it, because we don't really need to know much more about publisher policies, to be honest. If there's an opportunity, if we do follow along and there's an opportunity, maybe we will take a detour into that to see if it's worth our time. But as far as I'm aware of, I don't think it's that important. But there we go. Let us take a look at a consumer. So here's an example of consumer code. Very similar, kind of similar to the last one here. So we are creating a consumer client. And so here we need a connection string, container name, where we're going to put this stuff. Looks like we're going to put in Azure Blob Storage. We're going to create that client. And then we have a subscription. So the idea is that it's going to listen for data to consume. Okay, and then over here, we can see that it updates a checkpoint. We'll talk about checkpoints soon enough, but let's just talk about consumers in general. So a consumer, also known as a reader, receives data to process from the stream. All Event Hub consumers connect via the AMQP 1.0 session, and events are delivered through the session as they become available. The client does not need to pull for data availability. So that's that. We'll next talk about consumer groups. Well, let's talk about consumer groups here. This is very text heavy, sorry, but there's not much to show. A consumer group is a view, state, position, or offset of an entire event hub. Consumer groups enable multiple consuming applications to each have a separate view of the event stream and to read the stream independently at their own pace with their own offsets. So in a stream processing architecture, each downstream application equates to a consumer group. There's always a default consumer group in Event Hub, and you can create up to the maximum number of consumer groups for the corresponding pricing tier. There can be at most 5 concurrent readers on a partition per consumer group. However, it's recommended there's only 1 active receiver on a partition per consumer group. Some clients offered by Azure SDK are intelligent consumer agents that automatically manage the details of ensuring that each partition has a single reader and that all partitions of an Event Hub are being read from. This allows your code to focus on processing the events being read from the Event Hub, so it can ignore many of the details of the partition. So there you go. Well, let's talk about offsets for Azure Event Hub. So an offset is the position of an event within a partition. And so here's an example, a very ugly graphic from the documentation, but it makes our point clear. The idea is you have a partition, you have an event within the partition. There's all these little lines represent event, and that's where our offset is. So offsets enable a consumer or reader to specify a point in the event stream from which they want to begin reading events. You can specify the offset as a timestamp or as an offset value. Consumers are responsible for storing their own offset values outside of the Event Hub service. Within a partition, each event includes an offset. So there you go. All right, let's talk about checkpointing. There's really not a lot to say about it or to visualize it, but it's kind of part of offsets. So checkpointing is a process by which readers mark or commit their position within a partition event sequence. Checkpointing is the responsibility of the consumer and occurs on a per partition basis with a consumer group. The responsibility means that for each consumer group, each partition reader must keep track of its current position in the event stream and can inform the service when it considers the data stream complete. Something that is not uncommon when we're looking at event buses. There's something similar in AWS. And the idea here is that you're able to enforce a particular schema of your data, and this will help avoid things breaking for your consumers and have a standard way of expectation of what something is. So the idea here is Schema Registry provides a centralized repository for schemas. This provides the flexibility for your producer and consumer applications to exchange data without having to manage and share schemas between them, and also evolve at different rates. That's the key thing there, evolve at different rates. So here we have our schema group. We have a schema. We'll talk about schema group in a second. And then you have schema versions, and then there's the actual schema itself. So schema groups are under your namespace and can be accessed by all topics, event hubs under that namespace. So here you can see we were just setting some options here. And then here's the schema itself. So here we have a very simple example where we have a type of record and name ordered, and we have a couple of fields. But the idea, again, is Schema Registry really does help you kind of enforce what you expect data to look like for your producers, for your consumers, and there you go. We are taking a look at Apache Kafka. So the reason we're talking about it is just because Event Hub has a compatibility mode for it. So Apache Kafka is an open source streaming platform to create high performance data pipelines, streaming analytics, data integrations, and mission critical applications. Kafka was originally developed by LinkedIn and open source in 2011. Kafka was written in Scala and Java, so to use it, you'll need to know how to write Java. And the idea is quite simple. We have producers, we have consumers, we have topics, there's a cluster, there's partitions. Looks similar to Event Hub and other kind of streaming platforms. In Kafka, data is stored in partitions, of course, that span multiple machines because it's for distributed computing. You have producers via the Kafka Producer API. You have consumers via the Consumer API. Messages are organized into topics. Producers will push messages to topics. Consumers will listen on topics. So let's talk about that Kafka compatibility. So Event Hub provides an endpoint compatible with Apache Kafka producers and consumers APIs for version 1 and above. So Event Hub Kafka compatibility is alternative to running your own Apache Kafka cluster. So we said that they're very similar. So Event Hub calls them namespace, Kafka calls them clusters. So you can kind of see that there's that translation over. But the idea is that when you enable this, it will use all the stuff that Kafka is used to seeing. And then the idea there is that you don't have to run a Kafka cluster. You just run Event Hub. If you've already written code that works with Kafka, that's the idea, is that you can drop in Event Hub as a managed replacement. Now, does Event Hub work exactly like Kafka? I'm not 100% sure. So there could be some feature differences. But in terms of protocols or endpoints, being able to replace Kafka with Event Hub if you need to, that's why they have this functionality here. So there you go. We are looking at partitioning or partitions for Event Hub. So Event Hub organizes sequences of events sent to an Event Hub into one or more partitions. As new events arrive, they're added to the end of the sequence. So the idea is that you have those partitions, olders on the left, newers on the right. Partitions hold the following data about the event: the body of the event, a user-defined property bag describing the event, metadata such as its offset and its partition, its number in the stream sequence, service-side timestamps at which it was accepted. Partitioning allows for multiple parallel logs to be used for the same event hub, and therefore multiplying the available raw input-output throughput capacity. You can use a partition key to map incoming event data into specific partitions for the purpose of data organization, and the partition key is a sender-supplied value passed into an Event Hub. So there you go. We're taking a look at event retention for Event Hub. So published events are removed from an Event Hub based on a configurable time-based retention policy, and the default value and shortest possible retention period is 1 day. So that's 24 hours. For Event Hub's standard, the maximum retention is 7 days. And we saw that in the pricing page where retention can be different based on those things. So for premium and dedicated, the maximum retention is 90 days. If you change the retention period, it applies to all messages, including messages that are already in Event Hub. You cannot explicitly delete events. The reason for Event Hub's limit on data retention based on time is to prevent large volumes of historical customer data getting trapped in a deep store that's only indexed by timestamp and only allows for sequential access, which doesn't sound too good. If you need to archive events beyond the allowed retention period, you can automatically have them stored in Azure Storage or Data Lake by turning on Event Hub's capture feature, which we talked about earlier. If you need to search or analyze such deep archives, you can easily import them into Azure Synapse or other similar stores and analytics platforms. So there you go. In this follow along, we are going to learn all about Azure Event Hub. So what I want you to do is go to the top here and type in Event Hub, and we are going to create ourselves a new Event Hub namespace. So we'll go here and hit create, and we'll create a new resource group as we always do and call it My Event Hub. And then for the namespace name, we'll say My Event Hub. If it doesn't let you do that, you'll have to put some numbers on the end. I'm just putting some numbers here because often these are taken up. Doesn't matter what location it is, just choose whichever one. We're going with basic because there's not a huge difference between the pricing terms in terms of feature sets that we want to use today. So we'll go ahead and create this namespace. So we'll give it a moment and we'll go ahead and hit create. And then we'll just wait for this namespace to provision. All right, so after waiting about a couple of minutes there, our namespace is deployed. We're going to go ahead and create ourselves an Event Hub. I'm going to call this one My Hub. We'll go ahead and hit review and create. And we'll create. And these create very, very quickly, so we're not going to have to wait too long. We need to set some shared access policies here. So I'm going to go into the hub here. We're going to hit manage. I'm going to call this My SAS. SAS, shared access policy. And there we will now have the ability to have a primary key and connection key so we can actually connect to it. So what we're going to do is go to GitHub, and I want to create a new repository. And we'll go ahead here. And we'll go down below, go to ExamPro. We'll say My Event Hub. That's already taken because I've done this before. So for mine, I'm going to call it new. And we'll go down to private. We're going to use Node.js, so we'll just type in Node.js so that it ignores the Node modules. You're going to want to have Gitpod or a Visual Studio Code installed on your computer. The easiest way is honestly Gitpod because these environments are temporary and it's free to utilize it. So if you can, go get the Chrome extension, or if you don't want to install the Chrome extension, all you got to do is attach this to the end of the repo to launch a GitHub or Gitpod environment. So give that a moment to launch. And there we go. So I do have some code for this. So I'm just looking for it off screen here. And we're going to need to have a couple files here. We're going to need a new file called send.js. And we're going to need a new file here called receive.js. I'm not typing the full word receive because I'm always really bad at spelling it. So I'm just trying to save myself some trouble. And we're also going to have to initialize a new package.json file. So there we go. And we're going to have to get a couple things installed. Yeah, so we'll need npm install Azure Event Hubs, Azure Storage Blob, Azure Event Hubs checkpoint, store blob, save dev. And to make our lives a bit easier, it seems like I typed something wrong here. I'll just hit up. I forgot the / here. And so we'll just go Event Hub, Azure JavaScript. Because I believe, yeah, I kind of use this one, but I modified it to make it a little bit easier. I think this is the one I was doing. No, I don't think so. Tutorial. Might be this one. Yeah, it looks like this. So this is just the JavaScript there. So for send, we will grab this code here. We're not going to do exactly the way they do it, but pretty close. And then there is a receive code. So we'll go down below and we'll grab this. As you can see, there's a lot going on here. That will be our receive. A couple things we need to properly set. So these will be all environment variables. So what we'll do is go to the top here and we'll just do constant process requires process. That's going to allow us to import our environment variables. So we'll just say copy. We'll just save that. We'll paste that in there as well. And then this is where we need to replace all our environment variables. As you can see, I always have things pinging up on me here, so I'll just close my teams out. And I'm just lining these to make this a little bit faster. So default will be what we'll keep here. This will be our storage connection string. Say process, env, storage connection string. Then this one will be process env container name. Then we need process env event hub name. And up here we'll have process env event hub connection string. And then we'll go over to our send here. We'll do something very similar. So process env event hub connection string. And then we'll have process env event hub name. So we need to set all of these. I'm just going to copy this for a moment here. I'm going to make a new file. File, new file. Sure, it doesn't really matter. We're just using this as a quick scratch pad. And so what I want to do here is just delete out this part. And we're going to do export on the end here. We'll take out this one here. And the idea is that we'll just set them all here, and then we will make our lives a little bit easier when we have to mass set these. So we do have the connection string because we saw it over here. So we'll grab the primary one. Doesn't matter which one, primary, secondary. And that is for the event hub. We called the event hub was called my hub, I believe. We'll just double check what the hub was called. Yeah, it's called my hub up there. We'll need a storage account. So what I'm going to do, wish this thing would get out of here. Get out of here. I'm not trying to save a frickin' file. There we go. Hit escape a bunch of times. And we'll go back here and we'll create ourselves a new storage account. I'm going to actually make this in a new tab so we can see what we're doing. So we'll go over to storage accounts. And we'll create ourselves a new storage account. We'll create this storage account in the same namespace. So we'll go down to my event hub. We'll just say my event hub 8888. Again, you might have to change it based on your standards, but or like what is available to you. We'll go ahead and go review, create. And for the container name, we'll probably just call it container. Maybe container 1. We just have to wait for this to grab that connection string. So this usually doesn't take too long, just a couple seconds. Okay, so there we are. We'll go over to access keys, and we'll grab the connection string from here. I believe this one should work. Let me just double check. Yeah, I think this will work. So what we'll do is go back over here. If it doesn't, we'll find out pretty soon, and we'll just generate out a shared policy. We'll go ahead and paste that on in here. And just double checking that this is the correct one. This looks identical to that one. That can't be correct. So we'll go back here. This is the storage account. So we'll go, oh, I have to actually hit the copy button. That's what I didn't do. We'll go ahead and paste that in. And so theoretically this should work. So we'll go ahead and copy these. We'll drag our terminal up a bit. We'll paste these in here. And what I'll do is just double check that they're here. So we'll say env grep event hub. So those are both set. And then we'll do storage. That one is set. And we'll do container. That one is set. So these are all in good shape. For our storage account, we still have to create the container. So go here and create a new container. Say container 1. We'll go ahead and create that. We'll make our way back over here. And then instead of just having export, we'll do gp env. This is just in case we have to restart the environment for any reason so that these environment variables get exported twice. So we'll paste that in there. I believe those are all set. Go ahead and hit enter on the last one there. And let's see if our code works. So we'll do a send. Actually, we have to set up 2 scripts here so that we can actually call them. So one called here is called send. This will be node send.js. And we'll have receive, so REC. Just because I always spell receive wrong and I just don't want to have to type it 1,000 times, we'll have that there. So now what we'll do is do npm run send. See if that works. It says a batch of 3 events have been sent. We'll go and confirm that over an Event Hub if it worked. If we go to the overview, it should show us some messages were received. Sometimes there's a bit of a delay. So we'll just give it a teeny tiny amount of time. We'll hit refresh here, because we know we sent them. But while we're waiting for those to kind of propagate, what we'll go back here is just kind of look at the code, because we didn't really look at it. So the way it works is you are defining a client, and it will be the producer client. And then down below, so we say, okay, a producer is someone that produces events. It's very common in a messaging system to have a producer and consumer. We're going to create a batch job, and we're going to add them all to the batch job. Then we're going to send them all at once, and it's going to close, and it'll complete. And if there are any errors, it will alert us about it. So we'll go back over here, and we'll do a refresh. So I want to see messages. Messages would normally show up here. So since I don't trust it, I'm just going to run it again. I mean, clearly worked because there was no errors. And we'll go back over here, and not here, but we'll go back here. We'll refresh. And I'm just waiting to see something here. Processing data. This is like something that's really powerful with Event Hub here. So still don't see the messages. Just give me a second to debug this. I've done this lab like 4 times, so it should work, but you know, sometimes there's trouble. So just a moment. All right, so I literally did nothing, and now it's actually showing up in the messaging queue. So, you know, or the hub, the funnel. So that's just something you have to consider, is that sometimes you just have to be a little bit patient. Let's see if we can go receive those messages now by running the other script. So what I'm going to do here is do npm run receive, and it should receive the messages as long as something isn't typed incorrectly. So we'll go back over here. We've seemed to introduce a little mistake, so I'll go ahead and save that. We'll hit up, and it should receive the events. So it should print the 3 out. So there we go. And so we are streaming this, or the consumer is technically storage accounts. But if we go to the storage account, there's nothing really intelligible in terms of what's in here. So like there are stuff in here, checkpoints. I guess it's saved to checkpoint. I personally don't know what I'm looking at, so I'm not exactly sure what the point of doing that. I guess it's just saying the checkpoint is like the last point it wrote. But if we just take a look at the code here quickly, you can see that it's called consumer, so we can hit a consumer client. There's a blob checkpoint store. Then we have the consumer client. We are subscribing, so it's saying, hey, are there any events? Let's consume them. If there are no events, throw a console log, so tell us about it. Iterate through them, then update the checkpoint. So move it to the next point. Just say, hey, this is where it is now. And that's pretty much all I wanted you to do. We can go ahead and save this code. So we'll say Event Hub code. Doesn't matter what you name it there. We'll sync the changes, and we'll go ahead and clean up. So we'll go back to our resource groups. We'll go to Event Hub, and we will then go and delete this resource group. And we'll go here, and there you go.
Hey, Brian here again from ExamPro. Thank you for watching the video. Much appreciated. If it really helped you out, then don't forget to like, and if you want to keep learning, then go ahead and subscribe, and we're going to have all sorts of cool cloud content. If you're prepping for certifications or exams, or just want to learn more in a more structured way, you can go to exampro.co, and you get to see all sorts of awesome content there, including you get flashcards and quizzes and all sorts of great stuff. You could become a real professional on there, so go ahead, hop over there if you need to, or you can watch some of these videos that are popping up. Thank you so much for watching, and we'll see you soon.